Hi guys, so I wanted to make this video to focus on how to do logarithmic equations. So if you guys give me 1 second. Okay, so these first ones that I'm gonna do are gonna be very simple. So these first logarithmic equations are gonna be very simple. They're not gonna be very hard. So the first one that we're gonna do, and you have to make sure you know your logarithmic rules. Log base b of xy equals log base b of x plus log base b of y. And then basically the rules that would count. So basically, like, and also the other rule, basically x to the m over n, or let me just say x to the a over b, or actually no, m over n is equal to the nth root of x to the m, or the nth root of x all to the m power. That's the main rule that, those are the main rules that, you know, I would definitely remember. Also, log base b of x over y equals log base b of x minus log base b of y. Also, the power rule, log base b of x to the p, or log base b of x to the p equals p log base b of x. Basically bringing down the power and putting it in the front of the logarithm. And then the last one, which I forget all the time, which is the change of base formula. Give me 1 second. Okay, so it's gonna be log base b of a equals log of basically log of a. So log of a over log of b. So those are the kind of the formulas that we want to remember. Now, looking at the first logarithmic equation that we're going to do, these are pretty simple. They're not going to be like crazy. I want to start off very slowly. So we have log base 6 of u equals 1. Now, whenever I think in a few videos ago, I was explaining like how to do like the properties of logarithms and stuff. Basically log base b of y equals x if and only if b to the x equals y. That just means that if we have 2 cubed equals 8, that means that log base 2 of 8 is 3. And so, yeah, that's basically what it's saying. Now, for this one, what you want to do, there is a rule that says if you have a to the log base a of b, you cancel these out and you get b. Okay. So for this, what we're going to do, we're going to say that 6 to the log base 6 of u power is going to be, and what you're going to do is you're going to bring 1 up to a power, but you're going to get the same base. So you're going to say that it's going to equal 6 to the first power, okay? So basically, that's how you would do it, and then you would say, okay, so then it's going to be u equals 6. It's kind of weird when you first look at it because it's not really straightforward. But you just have to remember how it works. Anytime you're going to be using this rule a lot with logarithms. It's basically how you solve them. So the second one that we have is log base 6 of t equals 2. So my first step is, and you can always try to make this into a exponential function. So that means that, if log base b of y equals x, then b to the x equals y. You can say, so basically I can get my 6, and I can look at my 2, and I can say, oh, 6 squared is going to be t. So t equals 36. Okay, that's how you would do it. It's very useful for these types of problems. So the next one that I have is log of t equals 3. So with log of t, you have a base of 10. So just put a little 10 right here if you want. This just means that we're going to have 10 raised to the log base 10 of t power equals 10 cubed. So we have t equals 10 cubed, which is 1,000. Okay, I think it's 1,000. Let me just double check. Okay, yeah, it is. So it's 1,000. So t is going to be 1,000 for this one. And so the next one that we have, this one's a little trickier. And this is kind of why in the last video I did the power functions where I said, or basically not the power functions, but the radicals, where I said a to the m over n equals the nth root of a to the m. So this one is log base 4 of x equals 1/2. And what you're going to say is 4 to the log base 4 of x equals 4 to the 1/2. So you have log of x, or no, not log of x, excuse me. So, okay, so we're going to go ahead and do 4 to the log base 4 of x. It's going to cancel these out, okay? And we have equals 4 to the 1/2. So it's going to be x equals 4 to the 1/2. Now remember what I said, that anytime we have a to the m over n, that's the nth root of a to the m. That's why, there's a whole reason why I went over that. In basically, anytime you have like 4 to the 1/3, you can say the cubed root of 4 to the first power. It's an entire rule for that. It's a square root or a root property, an nth root property. So this one is just saying that x is equal to 4 to the 1/2. So x is basically the square root of 4. And since it's the square root of 4, however, I don't think that, basically, I don't think that you would go ahead and say, you would go ahead and say plus or minus, because I don't think that you can take the log of a negative number. So I would say x equals 2, because you cannot take, if I say log base 4 of negative 2 equals 1/2, that's a false statement, because you can't take the log of a negative number. Okay, so my answer is just 2. Let's go to the next one. Log base 2 of v is 5. So 2 to the log base 2 of v is going to be 2 to the 5th. if you notice the pattern, you would see that anytime I'm doing this, I'm basically making my bases the same. It's just like exponential equations, but I'm putting whatever the log is equal to, I'm putting it as my power. So this one is a power of 5, and then this one, like this one I did over here, I put it as the power of 1/2. And then this one, I put it as a power of 3. And then, this one, I put it, this one I used square root property, or exponent properties, but I did the exact same thing. I said 6 squared is t. This one, I did the exact same thing. I put 1 as my power. So that's kind of the main idea with this. So basically, you're going to get that v is equal to 2 to the 5th, and 2 to the 5th, I think, is, so if I do 2 to the 5th, 2 times 2 times 2 times 2 times 2, that's 4 times 4 times 2, which is 16 times 2, which is 32. So v is going to be 32. Okay, so then we have this one. We have log base 16 of z equals 1/2. So again, you want to go ahead and put 16 to the log base 16 of z equals 16 to the 1/2. You're going to put your whatever numbers right here, you're going to move it to the front, and you're going to take the power of that, but you're going to put to the power of the log base 16 of z, because you want to get rid of your log. Now, these two cancel out. 16 to the 1/2 is just the square root of 16. The square root of 16 is 4. So z is going to be 4. And it's not -4, because -4 is not, I don't think it's, you can't take the negative log of, or the log of a negative number, so it would just be 4. And let's see, log base 7 of v, so for number 7, log base 7 of v equals 2, so we're going to say 7 to the log base v of, or log base 7 of v equals 7 squared, okay? The log cancels out, so we get v is 7 squared, which is 49, okay? Log base 3 of v is 3, so that's for number 8, log base 3 of v is 3, so we can say 3 to the log base 3 of v equals 3 cubed. So then this cancels out. V, or log also cancels out, so v is 3 cubed. 3 times 3 is 9, and 9 times 3 is 27, so your answer ends up being 27 for that one. And then we have number 9, which is log base 9 of z equals 2. And then we have so we can say 9 to the log base 9 of z is equal to 9 squared. We can say that z and our log cancels out, so z is going to equal 81. Okay. We're going to do one more of these, like with this basic logs. Okay, so if we do log base 4 of u is 3, we want to go ahead and, we want to go ahead and do it with, with u. So basically, we want to solve for u, and then we have 4 to the log base 4 of u. That's going to be equal to 4 cubed. And notice how, I keep putting, you're going to take, basically you're trying to cancel out your logs. So then that's how it's gonna, that's how you would do it. So then u is going to equal 4 cubed, and 4 cubed is 64. Okay. Okay, so we're going to switch gears, and we're going to go ahead and do one that is a little bit more complicated. So for this one, we're going to try to do one that's a little more complicated than what we've already been doing. So bear with me, guys. Hold on. Okay, so this one is a little bit more complicated. It's not really as complicated as what we've been doing. We have 2 log of r is 6. Now, anytime you have a number in the very front, what you want to do to get rid of it is you want to divide. So we're going to say divide by 2 on both sides, right? And then we can say that log of r equals 3. So then that means that log base 10 of r is 3. So that means that we have 10 to the log base 10 of r is 10 cubed. So then we can say r equals 10 to the 3rd power, which is 1000. Okay. Okay, so for this one, we have 4 log of u is 12. So we're going to go ahead and divide by 4 on both sides. So just change colors really quick. So if we can say log of u is 3, right? So then remember that log of u is log base 10 of u is equal to 3. So that means that because of that, 3 to the 10th is equal to u. Now, if you get your calculator and you actually do 3 to the 10th, so basically, you're going to get that, so let's see here, if you have 3 to the 10th, or actually, sorry, no, it's not 3 to the 10th, it's, so you have log base 10 of u is 3, so you're going to say 10 to the log base 10 of u equals 10 cubed. That means that u will be 10 cubed, that's just going to be 1000. Okay. Okay, so we're going to do another one that's a little more difficult. Log of w plus log of 10 equals 1. Now, if you remember from your log properties of logarithms that log of xy equals log of x plus log of y, okay? So that's kind of, so basically that's the rule. So here you're gonna have log of, basically you have log of 10w equals 1. Now, know that you have a base of 10, so you're going to say 10 to the log base 10 of 10w equals 10 to the 1st power. That means that 10w equals 10, so if you divide each side by 10, you get w equals 1, and that's your answer. If we do another one, we have number 14, which says log base 5 of r plus log base 5 of 5 equals 1. So that means that log base 5 of r, and notice that anytime we have something like this, if we have log base b of b, that's just going to be 1. So this will be plus 1 equals 1. So we have, if we subtract 1 on both sides, we get log base 5 of r equals 0. And then you have to use your power properties. So basically you say 5 to the log base 5 of r is equal to 5 to the 0th power. You're going to move the 0 as a power. You cross both of these out, and you get r is 5 to the 0 power, or r equals 1. Okay. Number 15, log of y plus log of 8 equals 3. Okay, so for this one, we have log of y plus log of 8 equals 3. So again, because we have log of xy is log of x plus log of y, we're going to go ahead and say that log of y plus log of 8 is log of 8y, and then that's going to be 3. Now, notice that we have a base of 10, so we have log base 10 of 8y is equal to 3. So we're going to get the power of 10, so we're going to go ahead and say 10 to the log base 10 of 8y power equals 10 cubed. So then that means that 8y is 10 cubed. 8y equals 1,000. And when you divide it by 8, you would get that y is, so give me 1 second. $125. So you get y is 125. For number 16, we have log base 4 of x plus log base 4 of 4 equals 3. So we have, again, because these two bases cancel out, so we can say log base 4 of x plus, and this becomes a 1 because log base 4 of 4, the bases cancel out, so it's just going to be 1 is equal to 3. And then you have log base 4 of x plus 1 equals 3. You're going to go ahead and subtract 1 on both sides. You get log base 4 of x equals 2. So then that means that, so log base 4 of x is 2, so you can use your properties of logarithms to, or your exponent rules. Since log base b of y equals x, that means that, basically, so we have log base 4 of x equals 2, so b to the x equals y, so then that means that 2 to the 4th equals x. Or you could also do it this way, where you say 4 to the log base 4 of x equals 2 to the 4th. And that will give you the same exact answer. X is 2 to the 4th, which is 32, I think. Or is it? No, it's 16. 16. For number 17, we have log base 4 of r, so it's the same exact thing. Log base 4 of r plus log base 4 of 4 equals 3. So we have log base 4 of r plus 1 equals 3. So we subtract 1 on both sides, we get log base 4 of r equals 2. And then we go ahead and say 4 to the log base 4 of r equals 4 squared. Okay. We move the 2, we move it as a power, and we get the bases the same. We go ahead and cross these out, we get r equals 16. Okay. So I think I want to go ahead and do just a few more, for this video. So I'm just gonna go ahead and do a little bit more difficult ones. So give me 1 second. Okay, so we're gonna go a little bit more difficult now. It's the same thing we've been doing, it's just a little more difficult now because, you know, I want to make sure that, you guys understand how they work. So basically, we're gonna do this one. Log base 2 of x plus 1 minus the log base 2 of x minus 4 equals 3. Now, notice that they both have a log base 2, and notice that they're both being subtracted. Remember the formula that says log base b of x over y equals the log base b of x minus the log base b of y, okay? So basically you're going to go ahead and put this so that it can be put as a division, kind of the logarithm of a rational. So you're gonna have the log base 2 of x plus 1, and it's going to be x plus 1 over x minus 4 equals the log base 2 of 3. Or equals 3 rather. It's going to be 3. It's going to be equals 3. You're not going to take the log of both sides yet. Because that's not, please do not do that. Do not say log base 2 of 3, because then you're going to think that this is what you make it equal to. Just keep it as it is, okay? Now what you're going to do, you want the bases to be the same, right? So you're going to say 2, and then you're going to say 2 to the log base 2 of the quantity x plus 1 divided by x minus 4 equals 2 cubed. So this cancels out. You have x plus 1 over x minus 4 equals 2 cubed, which is 8. You're going to go ahead and multiply x minus 4 on both sides, and you have a linear equation which says x plus 1 equals 8 times the quantity x minus 4. You do distributive property, you get 8x minus 32. From there, all you have to do is just, this is a simple linear equation, you just go ahead and subtract x on both sides, and then you say 1 is equal to 7x minus 32. So then after that you add 32 on both sides, and you get 33 equals 7x. So then that means that x equals 33 over 7. Now you can always check with a calculator to make sure that that's exactly what it is. So we can go ahead and go on Desmos and see if that's actually correct. So we want to check this to make sure that it's equal. Now we're going to go ahead and do that. We have the following. We have the log base, we're going to say the log base 2, so the log base 2, if we go over here, the log base 2 of 33 over 7 plus 1, plus 1 minus the log base 2 of 33 over 7 minus 4, so minus the log base 2 of 33 over 7 minus 4, and that does equal 3, so this is our final answer. So 33 over 7 is an answer to this equation. Now, you're only going to have to do that, I mean, you can do it for every equation because sometimes, you know, it's just better to be safe than sorry. You know, just to be on the safe side, I would always check on every equation. But yeah, so, let me see if there's, I'm gonna just go over one more really quick, and then that'll be the end of the video. Okay, so we have this one, the log base 6 of x plus 4 plus the log base 6 of x minus 2 equals the log base 6 of 4x. Now, again, when you do the log base b of y, or the log base b of x times, or plus the log base b of y, you want to make sure you bring the x and y together. So you're going to say log base 6 of x plus 4 times x minus 2 equals the log base 6 of 4x. So because the bases are the same now, we can make these two equal to each other. So we can say x plus 4 times x minus 2 equals 4x. Now, to solve this for x, we're going to do the FOIL method. So we have x squared minus 2x plus 4x minus 8 equals 4x, and we have x squared plus 2x minus 8 equals 4x. If we go ahead and subtract 4x on both sides, we will get that x squared minus 2x minus 8 equals 0. So then the answer, so then once we factor them, we're going to factor this out. We have 1 and negative 8, that's negative 8, 1 times negative 8, and then we have a negative 2 on the bottom. So two numbers that multiply to negative 8 and add to negative 2 are negative 4 and 2. So we have x minus 4 times x plus 2 equals 0. So then our answer will be x equals 4 and x equals negative 2. However, you want to check your equation to see if it's actually true. If you do the log base 6 of x plus 4, so log base 6 of negative 2 plus 4, for example, plus the log base 6 of negative 2 minus 2 equals the log base 6 of 4 times negative 2, which is the log base 6 of 2 plus the log base 6 of negative 4 equals the log base 6 of negative 8. Okay. So here's the thing about negative numbers inside the logarithm. You cannot have negative numbers in the logarithm, okay? So because of that, you would have log base 6 of 2. This is undefined, and this is undefined. So that means that x equals negative 2 is not a solution. Okay. So the only solution for this equation is x equals 4. Okay. And we can always check it. but yes, it is because, you know, I did check it myself and it is the solution. So, yeah, so that'll be the end of this video, guys. I know it was a pretty long video, but I hope this helps, guys, and I will see you guys in the next video. Bye, guys. Oh, and thank you so much for watching, and please like, comment, and or subscribe to my channel for more math content. If you guys have any questions, please comment down below. And yeah, bye, guys.